In this video, we're going to show how to use Simcenter Testlab's feature called MultiRun Modal. It's used to correct mode shapes that come from different FRF measurements that were not all acquired at the same time on a structure like this transmission housing. For this transmission housing, I would love to have some nice looking mode shapes, but there's some challenges. If I look at the FRFs, I had to acquire them in 6 different acquisitions. First set of FRFs I took, I can use some of those FRFs here. I can also look at maybe the last set of FRFs I took, and I had to move accelerometers around each time. If I zoom in a little bit, I might see, for example, that on this particular peak, these 2 FRFs, the red and magenta that came from my last set of data, the frequencies are consistent, and they're different than the peak frequency that came from my first set of data, the blue and green curve. The frequency shifted a little bit. That makes it challenging to go in and extract the right modal characteristics, mode shapes, etc. from the data. Here in the Polymax curve fitter, I have a summation of all the FRFs showing here, and by default I'm looking at all the runs. And you can see that instead of a single clean peak here, I have multiple peaks, for example, in the summation. If I look at just one of the runs, then I have a single peak. And if I look at all of them, multiple. And what we want to do in MultiRun Modal is select one of the runs. We'll go to the stabilization diagram, calculates it. We'll select poles from it. And then we'll go to shapes here and do a calculation. And we have an incomplete mode shape. Only some of the points are moving, just the points that were used in that particular data acquisition run. I'm going to go back and I'm going to analyze the other runs. So if I go to run 3 here, for example, I go to stabilization, I select poles, I get a new set, I calculate the shapes, and then I start comparing those. Different points are moving. And I do that for all 6 runs. Then I can go to MultiRun Modal. I'm going to select one of the runs as target modes here. And the target modes are basically the frequencies that we'll use for each mode shape for our final set of data. Then I go to each partial shape and I select the modes in each partial shape here and say add. And the partial shape at 466 will now be going to 468.94 in the target mode set. The partial shape here will be combined with this partial mode shape, 581 with 581, 715 with 713, etc. And I'm going to do that for all 6 runs. And what I'm going to end up with is a complete mode shape, hopefully, in the end, but without any confusion about the shift. So I go to merge modes, I hit merge, and now I have complete mode shape with the target mode frequency, but the shapes result from all 6 runs. The alternative would have been to analyze all of this data at once, all the runs. If I did that, notice the stabilization diagram becomes quite busy, and you don't know which S is the real S here that represents the mode, because there's multiple columns of S's at each peak. And I could have tried to use this to analyze the data, but I would have gotten some strange mode shapes. If I go to modal validation here, I can compare some of these mode shapes. And I did this analysis in advance, so it's mode shapes from all the runs analyzed at the same time versus merged modes from analyzing each run individually and then calculating a combined mode shape. If I calculate the MAC here, I can start to see what the MultiRun Modal did for me. So I got on this side my merged mode shape. Notice it's a very clean shape. Over here, the all runs mode shape is not quite correct. It has kind of a complex wavy motion, and that's not normal in a metallic structure like this. Other mode shapes, nice looking mode shape over here, not so nice over here, complex and wavy. If you're going to do a comparison back to FEA, for example, modes calculated from Nastran Solution 103, those are normal modes. And you can see that we have a normal mode shape where all the points are in and out of phase when we use the MultiRun Modal approach. And we do not have a normal mode when we look at the mode shape that results from multiple runs being analyzed simultaneously. Thank you very much.